All right, so today we are doing our lesson on 16.3, the unit circle. I have a handout that you should see this circle shape on for our Google Classroom post, so you'll need to have this printed and ready because we will need it for our notes before we even start our notes today. Typically, I spend a day kind of talking about what this circle is, so we're just going to spend some time doing it right now, and then how we use it is very quick, but we have to understand how to get everything on this circle. All right, so it's essentially the coordinate plane. Okay, so I have, like, this would be my y-axis, and that's my x-axis. All right, so I'm breaking it into, here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, whether you want to fill that part in or not, I might quick erase that just because it's going to cover up blanks that I'm going to put in, so it might be confusing for you to see that as I fill in everything on here, but that's our visual of what's happening. All right, so we're going to start here in quadrant 1 and just kind of work from there. If you can figure out quadrant 1, you can kind of figure out the rest of this whole thing. Okay, so we have these little lines here. And so we are labeling things in both degrees and radians. All right, so that can be considered 0 degrees. The slash is for, if I go all the way around the circle and I come back, that would be 360 degrees. So it means both. All right, what we talked about yesterday, well, 0 degrees would be the same as 0 radians. So this other side here, without the little degree symbol, is representing your radians. And we talked about all the way around is 2 pi, has to do with the circumference of a circle. So that slash, you'd have your 2 pi. Okay. If we think about, if I keep kind of going around, so where you'll see these degrees, this is where you're going to label all of those angles. All right, so let's just go around and label some angles we're pretty familiar with right now. So I got 360 and 0. Up here would be 90 degrees. Right, coming back down would be 180 degrees. Going another 90 degrees would be 270, and then you're back to 360. So those are ones that we're pretty familiar with, that we worked with already. The other line next to it, or underneath it in some cases, that's for what that angle would be in radians. So yesterday when we were doing lots of converting, we talked about, well, pi radians is the same as 180 degrees. Okay. Well, if I have 0 radians, pi radians, halfway in between then would be a half pi radians, which we write as pi over 2. All right, so I go to 0, a half, 1 pi, and then I'm back here at 2 pi. So then in between 1 and 2 would be 1.5, but we're not going to write it as 1.5 pi. We would write that as 3 pi over 2. All right, now you could absolutely convert 270 degrees, by multiplying by pi over 180 and simplifying that, like we learned yesterday. But I want you to kind of get an idea for how it works with the circle so that I don't have to do that for every single angle all the time. All right, if I wanted to check my answers, absolutely I could do that. Okay? All right, so we're going to continue trying to fill in this whole thing. All right, let's come back to quadrant 1 again. Okay, so I've got this angle here in the middle. So that's exactly in between 90 degrees and your 0 degrees. So this is going to be 45 degrees. Okay. If you want to convert that, if you're familiar with that just from doing your homework yesterday, you can. Let's go ahead and convert it right now. And then I'll show you a little pattern. So we'll convert it. All right, so I'll have 45 over 180 if I divide each by 45, 45 goes into 180 4 times. So this is pi over 4. So that's what that other line is for. All right, because what it's doing with your pi over 4, or every 45 degrees, you're kind of splitting that top half of our circle into 4 parts. All right, so I have 0, a fourth, another 45 degrees, which would now be a half, another 45 degrees, and then another 45 degrees would make your 180. All right, so there's little patterns. We're breaking the top half of the circle into 4 parts. All right, every 45 degrees, if that makes sense. Okay, so then if I think about that, so if I take my 90 degrees and I add 45 degrees to that, I would be at 135. And then if I add 45 degrees there, I'm back at my 180, if that makes sense. So now you can absolutely convert 135, multiply it by pi over 180, or you can kind of think about what's happening with this pattern as well, just to kind of save some time. So I'm cutting things into fourths, right, with this one, because every 45 degrees cuts it into 4 parts. So I have 1 pi and I have half pi. In between a half and a whole would be 3/4, right? A quarter, a half, 3/4, a whole. All right, so this will end up being 3 pi over 4, if that makes sense. All right, yes, you could absolutely convert that. All right, but I want you to start seeing some of these patterns so you don't have to all the time. Okay. So when I come back to quadrant 1 here, I'm going to use, so I've got my 45 degrees. If you can think about, we've done a lot of things with some special right triangles. Maybe you have an idea of what those other angles are representing, right? We're going to use our 30 degrees and our 60 degrees. So this is kind of bringing everything we've done in trig so far into one place. All right, so this is my 30 degrees. All right, ours isn't really to scale necessarily since it's kind of a stretched circle. It's a bit of an oval. But these lines right here are splitting that 90-degree angle into 30-degree parts, right? So 3 30-degree parts. All right, which means this would then be 60 degrees. All right, so that's what's representing on your circle. All right, let's go ahead and convert our 30 degrees and our 60 degrees, and then we'll try to kind of use that pattern to continue. So 30 degrees, if you multiply that by pi over 180, you're putting 30 over 180. If you take and divide out 30, we'd be left with pi over 6. So pi over 6 would represent 30 degrees. They'd be the same angle. One's in radians, one's in degrees. Okay, if I go ahead and convert 60 degrees, all right, if I divide both of those by 60, I get 1 pi over 3. All right. Eventually, we just kind of want to be familiar with 45 degrees is pi over 4, 30 degrees is pi over 6. How do you get it? Basically, if you just take 180 and divide by 30, you have your denominator. Okay, so should be some quick math if you are still, it's not coming to you right away. Just like I wanted you to be familiar when you see sine of 30 and you know that's a half kind of thing. When we see sine of pi over 6, we know that goes with 30 degrees, so that would be a half. All right. So that we're not having to convert every single time like you're having to do in your problems in your homework yesterday. All right, could you? Yes, you could. All right, okay. So continuing on, so right here, that would be 60 degrees. right? So if I travel another 60 degrees from where that pi over 3 angle ended, that would be right there. Does that make sense? So if I add 60 degrees to 60, this angle is at 120. All right, then you had to find things like cosine of 120, and then you find, oh, the reference angle is 60 degrees, so I can use the ratio for 60 degrees. We did things like that. All right, so 120 is going to be an angle that we can figure out some ratios with. We want to know what that would be in radians. Yes, you can convert that. But if I am in 60 degrees, I'm splitting 180, into 3 parts. Right? If I divide 180 by 60, it's going into 3 parts. All right, so if I have 1 pi over 3 at my 60 degrees, this is my second pi over 3. Here is my third pi over 3, which is 1. Okay. Let's go ahead and get these angles in degrees and radians. All right, that is 30 degrees away from 180. So you could get this by taking 30 degrees away and going, well, that would be 150, because 30 is that reference angle there. You can convert that, but every angle that's 30 degrees away or as a reference angle is going to use pi over 6, because I'm splitting up this top half of the circle into 6 parts, all 30 degrees for those 6 parts. All right, but if I do that, so here's one of those, right? There's 30 degrees. Another 30 degrees is here, which is at 60. Another 30 degrees is at my 90. All right, another 30 degrees, I'm at my 120. And then I'm at my 150. So how many of those did I go? Well, I would have counted 1, 2, 3, 4, 5. So this would be 5 pi over 6. Or a whole would be 6 pi over 6. So 1 less of those would be 5. Okay, so right now we have the top half of our circle filled in for all of the angles. All right, we can continue to do that with the bottom half in this similar pattern. All right, so every time I am 30 degrees away from that x-axis, or 30 degrees would be my reference angle, it is going to be an angle that ends in pi over 6. All right, so another 30 degrees, I'd be at 210. Yes, you can convert that, but if this is 6 pi over 6, this is now 7 pi over 6. Okay, the angle here in the middle of all those here in quadrant 3, if you've noticed some patterns on how we can come up with these angles, these are always 15 degrees apart from one another, because 45 would be exactly in between the 30 and the 60. All right, so I can either add 15 degrees to 220. I can figure out what is the middle between 180 and 270. Lots of different things. So this would put me at 225, which is 45 degrees past 180. Okay, if I can add another 15 degrees to 225, or I can think about that these are 30 degrees apart to get that 240. It's up to you. Okay, lots of little patterns happening. I'll just go ahead and continue around and finish out my angles here. So I've got 270. If I go another 30 degrees, we're at 300. Right in the middle would be only 15 degrees more, so I'm at 315. And then I'm at 330, which is 30 degrees away from 360. Okay, you can convert all of those if you would like. I'll try to show you some patterns here so that you could be a little bit more efficient. So everything, like I said, that's 30 degrees away from your x-axis would be something that ends with pi over 6. All right, if I went all the way around, I've got 2 pi. So think about what that would look like in terms of pi over 6. That would be a 12 pi over 6, right? Because 6 goes into 12 2 times. So that means this angle right here needs to be 1 less than 12 pi over 6. So that would be 11 pi over 6. Okay. All right, if I'm looking at 225, that's exactly in the middle of that quadrant. So that's the one that's 45 degrees away from my 180. So that is going to end with a denominator of 4, because we're trying to split that bottom half into 4 parts. All right, so if I go back to, well, 1 is here, so that's 4 pi over 4. Now I'm at 5 pi over 4. Okay. We kind of skipped the middle, would be my 270 right here. So that would be my 6 pi over 4, which reduces to 3 pi over 2. So then my 7th pi over 4 is the angle that's in the middle of that 4th quadrant. Or I could kind of think of what the way I did it over here. 8 pi over 4 would represent my 2 pi. 1 less than 8 would be 7. Okay. All right, we have our last 2 angles here. So both of those would be, this is 60 degrees away from my 180. And then this one is also 60 degrees away from my 0 or my 360. So both of those will have the same exact denominator as every 60-degree angle. So they will all end with my pi over 3. Okay, so I have 1 pi over 3 here, 2 pi over 3 here, 3 pi over 3. So this is 4 pi over 3. All right, travel another 60 degrees, I'm at 5 pi over 3. Travel another 60 degrees, this would be 6 pi over 3, which is my 2 pi. All right, so we are counting with fractions. Oops, did I write over 5? That is silly. All right, so we have filled in all of our angles. All right, so typically we spend a lot of time talking about this and looking at each part. And then we look into, there's these little coordinates over here. All right, and those are what we're going to fill in as well. All right, because those are going to tell us information about these angles when we use trig functions. All right, so something that the unit, this is called the unit circle. The reason why it's called the unit circle is your radius is 1. Oops. All right, so we're going to fill in some of the easier points first. Okay, so right here's the center of my circle. So my radius goes from the center to the outside of the circle. And if that length is 1, that means the coordinates for the point on the edge of that circle would be 1, 0. Same way if I find, the point right here would be 0, 1. All right, because that length from the center to the edge of that circle would be the length of 1 since the radius is 1. If I have a point right here, that would be -1, 0. My point down at 270 degrees would be 0, -1. Okay. Now the other ones are going to have familiar points, but we need to go back to something for a second. So if I'm talking about 30 degrees, and I want to know the coordinates of this point, if I drop down, I might want to put this over here just for a little visual. And I made a right triangle, and this is 30 degrees. That means this is 60 degrees. We're going back to that special right triangle. Okay? But and I want to know the coordinates at this point. So I need, this would be my x value of that point. This would be my y value of that point. But what's going to happen this time is the hypotenuse has to be 1, because the hypotenuse is what's going to be my radius. And the radius has to be 1 on this circle. Okay? So what that means, we learned about, so the hypotenuse is double the length of the short side on a 30, 60, 90 right triangle. So that means y would have to be a half. Okay, and x would have to be 1/2 times the square root of 3, because it takes whatever that short leg of that triangle is and you multiply it by the square root of 3. So that means my y coordinate is a half, and my x coordinate would be 1/2 times the square root of 3. So we write that as the square root of 3 over 2. We have written down the square root of 3 over 2 and 1/2 many times in other places. Okay, so we're going to talk about that in a moment. Okay, I want to go ahead, since I have my 30, 60, 90 triangle right here, talk about when I get to 60 degrees, what that would mean. So if you drop down and you made a right triangle right here, I'm going to put that off to this side so I don't have a big old mess inside my unit circle. So this is now 60 degrees, this is 30. Once again, the hypotenuse has to be 1, since that's going to be the radius on this circle. So now here's the short side is going to be my x. The long side is going to be my y in this case. So the short side is going to be the 1/2. The long side is the square root of 3 over 2. Okay, so this time I'm writing 1/2 and then square root of 3 over 2. Notice the 30 degrees and 60 degrees use the exact same fractions, but they are switching the x and the y. Okay, that's an important thing to notice. All right, let's look at the 45 degrees. So I'm going to erase these and put up a different one. You've got some extra space on your paper. All right, so if I drop down from this point, drop down a side to create a 45, 45, 90 triangle. Okay, once again, 1 has to be the hypotenuse. All right, and we talked about, a while back when we talked about bringing back these 30, 60, 90 right triangles, the side lengths were x and x, and you take x times the square root of 2 to get the hypotenuse. So if I have the hypotenuse and I want to get the side lengths of those triangles, I must divide my hypotenuse by the square root of 2 to get those, but we would never leave it as 1 over the square root of 2. Those turned into the square root of 2 over 2, which should hopefully ring a bell when you see that, because we have written that down for many, many problems. All right, so that's going to be my x coordinate and y coordinate to get to that point that is right here. So I'm going to write the square root of 2 over 2 for x, comma, the square root of 2 over 2 for y. Okay, kind of a lot of work to get to where we're at right now. All right, but the whole point is to kind of understand where they're all coming from, and then eventually you'll kind of just see that they're there. Once you have the first quadrant, you really have everything else. Now it can be quick. All right, so every time I see an angle that is a pi over 6 angle, it is going to have the exact same coordinates, except I need to pay attention to what quadrant it's in. All right, so right over here is my pi over 6 angle, so that means it's going to have square root of 3 over 2 first, and then 1/2 second, because that's the order for my pi over 6 angle, but I'm in quadrant 2, so I need a negative x value. Okay, if I look at every Oh, I'll keep going with that. So here's my next, 7 pi over 6 is my next pi over 6 angle. So I use the exact same coordinates, square root of 3 over 2 and 1/2, but they are both negative in quadrant 3. My last pi over 6 angle is 11 pi over 6. So I use my square root of 3 over 2, comma 1/2 in that order, but my y coordinates are negative in quadrant 4. So I need a negative. Every angle that is your 60 degrees reference angle, or everything that ends with a 3 in the denominator, will have the exact same coordinates as my first one over here, which is flipped from the ones we just wrote down. But I have to pay attention to what quadrant it's in. So here's my next 60-degree angle, is my 2 pi over 3. So I'd write 1/2, comma square root of 3 over 2, but my x value needs to be negative. Hopping into quadrant 3, 4 pi over 3 would be this angle. So I would write 1/2, comma square root of 3 over 2, but they are both negative in quadrant 3. In quadrant 4, I would put 1/2, comma square root of 3 over 2, but I need a negative y value. So a negative square root of 3 over 2 would be the y in quadrant 4. Okay, it looks like a lot of stuff, but we're writing the same things kind of over and over and over. Okay, the last one I haven't done all the 45-degree angles, so every 45 degrees, or I should say every 45 degrees away from your x-axis, every 45-degree reference angle, or every time it ends with a 4 in the denominator for radians, they will have, everything will be square root of 2 over 2. And I got to pay attention to the x is negative in quadrant 2. Both x and y would be negative in quadrant 3. Square root of 2 over 2. Oops, I wrote that in the wrong place. This would have been 1/2 and negative square root of 3 over 2. This was my pi over 4 angle. So this would have been square root of 2 over 2 and a negative square root of 2 over 2. All right, we have filled out our unit circle. You need to hold on to that because we are going to use that for every single problem now. Okay? Now we're starting our notes. So usually I spend a day of class just doing that, but I figured, I don't know, I just figured at home no one would do anything if I told them you're just looking at this circle for a day. All right, so keep that next to you. We're going to use that. Let's recall back to one of the first things we learned in trig. We talked about sine, cosine, and tangent, and that sine was y over r. Okay, but in the unit circle, I said r would equal 1. So if I'm talking about the unit circle, sine of theta is just y. So cosine of theta was x over r. But if r equals 1, I'm just going to use x for cosine. Tangent of theta was y over x. That's not going to change, right? R is not involved. For cosecant, we'll just use 1 over whatever y is. And then secant, 1 over x. Cotangent wouldn't change. That's still x over y. Okay? So here's what you'll be asked to do. You'll be asked to find exact circular values or circular function values It might just say find the exact value. Sometimes I've seen find exact circular function value, so I kind of wanted the wordiest one, just so that if you see that, you know it means the same thing. So your problem might say sine of 3 pi over 2. Yesterday, you would have converted that to degrees, then used our tools that we've had before to come up with that. Right now, we are looking at, where's 3 pi over 2 on my circle? It's right here. All right, I want sine, which means I only need the y coordinate at that point. What is the y coordinate at that point? It's -1. I'm done. Okay, so I'm using that tool that took us a long time to create and starting to get this visual that I could maybe picture what's going on in my head, possibly. All right, if I asked you for cosine of 3 pi over 2, cosine would use the x-coordinate, right? And this is the point 0, -1 we're looking at on our circle. So cosine of 3 pi over 2 would be 0. Sine and cosine are pretty easy because you're using either x or y. If you're asked for tangent, possibly a little bit more math involved depending on how difficult your point is. This one's not a difficult point since I don't have any radicals there to worry about. But tangent would use y divided by x. We would never type that into Math Excel. All right, we would select the option that this is undefined. Okay. Let's look at another one. So if I give you a different angle, sine of 7 pi over 4. Okay, yesterday you would have converted that to degrees, figured out the reference angle, used either a table or some special right triangles to come up with that. Today I want you to take a look at your circle, find your 7 pi over 4 angle right here, and take a look at the point. All right, I asked you for sine. So that means you use the y coordinate at that spot. So that's negative square root of 2 over 2. Okay, so we're kind of combining everything into one visual to kind of do what we were doing before. Everything we've done is leading up to this magical point of the unit circle. Okay, so I could ask you about cosine of 7 pi over 4, you would just write the x coordinate. If I asked you about, let's say, tangent of 7 pi over 4, right, you have to take the x coordinate divided by the y coordinate. Don't make that more difficult than it is. You're dividing it by itself. Right, so I will get -1. But that should look familiar. All of our answers are still coming from when we created those tables. All right, but it's helping you remember what sign to use, because some of you have been forgetting that. It's helping you to picture that location, all right, and come up with that reference angle without having to calculate all those things. Now I want to look at, if I gave you something, let's look at a reciprocal function. And if you got a negative angle. All right, so -5 pi over 3. All right, so then I'd have students that would say, well, -5 pi over 3 is not on my circle. I know where +5 pi over 3 is. All right, so we got to go back to if I'm moving in a negative direction. So here's my start. I have to go down to 5 pi over 3 around. If it's too confusing for you, you can convert it to degrees and figure out where it would be in degrees and then find that reference angle. You can find the positive coterminal angle if you would like, You can also count. All right, so here's positive 5 pi over 3, right? That's going all the way around the circle, but stopping 60 degrees away from 360. So if I go negative 5 pi over 3, that's going all the way around the circle, but in this direction. And so then it's going to stop 60 degrees away from negative 360, or from 0 in this case. All right, so now here's the location. There's the point I am using. So you can still use negative angles and travel in the same way you would have before. Okay, so if I'm looking for cotangent, I need the x-coordinate divided by the y-coordinate. Pi over 3. 60 degree angle. So that was the order. Sorry, I was just going back and trying to remember. So I need to take the x-coordinate, divide it by the y-coordinate. I wrote it as your elementary looking division problem so that I can turn this into multiplying by the reciprocal. Okay, so this would turn into my 2's would divide. So I get 1 over the square root of 3, but we never left it as 1 over the square root of 3. That turned into square root of 3 over 3, which is what we wrote down. We had cotangent of 60 degrees in our table. Okay, so if you're starting to click into some of these things, you can use previous material that we've had as well, especially when coming up with tangent and cotangent. This is kind of more work than when we just kind of were familiar with our table in that case, but we're all getting it from the same thing. Okay, so that's the typical problems that you'll be doing. So not a ton of work. We did a lot of the work just creating that circle. You're using that circle to kind of visualize where things are at and come up with the x coordinates and y coordinates at that point. The last thing that you'll be asked to do is just calculator problems. So it might say to approximate So if it's asking you to approximate, you're now going to use a calculator. Okay, so these are likely ones that are not with one of our special angles. They do not have a 30 degree, 60 degree, 90 degree reference angle. All right, so then we have to have a calculator for them. Okay, so we are now going to need radian mode. All right, so go back into your calculator, select mode, and make sure you highlight radians so we're not in degrees. You will possibly have to flip back and forth on your test and be aware, because our test is going to cover everything. So make sure, yes, you are paying attention to what it's asking for. So especially if I have a problem like cosine of 1.85, I will have a lot of students say, is this in degrees or radians? It doesn't have a degree symbol, so it is not in degrees. I'm very picky when you turn in your paper test, which you're not going to have a paper test, but I mark things wrong when students do not put degrees next to it, because when we're in radians, it won't say cosine of 1.85 radians. It's just going to say 1.85. If I wanted it to say degrees, it would say 1.85 degrees. Okay, so radians doesn't have a label, degrees does. All right, so that's the part we need to make sure we're familiar with, and just double checking on our calculator that we are in the correct mode. Okay, so not hard, right? If you're in the correct mode, you type in cosine of 1.85, and then, you know, your Math Excel is going to say go out to those 8 decimal places or something fun. I'm not sure how many it is. I did 4. All right, so negative 0.2756 is as far as I went out. Make sure you follow what they ask for. Okay, and then same thing as if I gave you one of our reciprocal functions, you don't have that in your calculator, so 1.3209, there is no degree symbol, that's in radians. Radians is typically small numbers, decimals, 1, 2, nothing too big. All right, very typically, but I mean, it can really be many things. All right, to calculate this, I must use cotangent's reciprocal function, which would be tangent. So 1 over tangent of 1.3209. Type that in if I'm in radians. I went to 4 decimal places again. So 0.2552. All right, and that is it for our lesson today. Use that unit circle. We'll practice creating more unit circles. I have copies. You can print out more if you want from that post. All right, that's it. Yeah. Yeah. Yes.